Hello there, Mr. Sutton here, bringing you the Algebra 2 8-1 Part 1 homework solutions on sample space and probability. For this problem, they want us to find the number of possible outcomes in the sample space from flipping a coin and drawing a marble from a bag with two purples and one white. They also want us to list out the possible outcomes. So let's start with the total possible outcomes. We have two outcomes from flipping a coin. That would be heads and tails. We have three outcomes from drawing a marble. That would be purple 1, purple 2, and white. So I'm going to distinguish these two purple marbles with these little subscripts here. So the total sample space then is going to be 2 times 3, or 6. And now for the actual items, I'm just going to write each of the coin possibilities combined with each of the marble possibilities. So we have heads and purple 1, heads and purple 2, heads and the white marble, and then tails with all of those possibilities. So tails purple 1, tails purple 2, tails and the white marble. For this problem, we are randomly choosing a letter from A to F and then a whole number from 1 to 3. We want to know the number of possible outcomes in the sample space and then a list of those. So for the letters, we have 6 possible outcomes. That would be the letters A through F, so A, B, C, D, E, F. For the numbers, we've got 3 outcomes, the numbers 1, 2, and 3. And that means that we have 6 times 3 for the overall sample space with both of these happening. So that's 18 different possible combinations of these. And those combinations, we'll just list them out now. So we've got each of the letters followed by each of the numbers. So A1, A2, A3, and then B, 1, 2, and 3. And then C1, 2, and 3, D, 1, 2, and 3, E, 1, 2, and 3, and then F, 1, 2, and yes, 3. For this problem, we have a friend with 2 decks of 52 playing cards asking you to randomly draw a card from each deck. We want the probability that you will draw 2 spades. So the easiest way to do this, well, one way to do this would be to list out the possible combinations of what you could draw, and then just count up how many of those there are, get a sample space, and use that for your theoretical probability. So just to kind of reset here, standard deck of 52 cards. In each of these decks, we have 13 spades, and also 13 of each of the other 3 suits. So if you're just drawing a single card from each deck, you have a 1 in 4 chance of getting a spade, and a 1 in 4 chance of getting one of the other suits. So you have an even chance of getting all of them. So we're going to make a little table here that talks about how many spades we drew between these 2 decks. Our first row is the possibility of drawing 0 spades. Now this is actually the most complex, because if we're not drawing any spades, that means we're drawing one of the other 3 suits each time. So for example, one of the possible outcomes here is that we drew a heart followed by a heart. Another is maybe we had a heart and a diamond, and then a heart and a club. So those are the other possibilities. But now we also have the possibility that we drew a diamond for our first one and then a heart from the other deck, or 2 diamonds, or a diamond and a club. And then we also have the 3 possibilities where we drew a club as our first card. So club and a heart, club and a diamond, club and a club. That's a grand total of 9 non-spade possibilities. Now, for the possibilities where we do draw a spade, one possibility is that the first card we draw is a spade, followed by one of these 3 that's not a spade. So spade and a heart, spade and a diamond, spade and a club. The other possibility is that we drew a non-spade for the first card and a spade for the second card. So heart, then a spade, diamond, spade, club, spade. And then our last row here is the possibility of drawing 2 spades. So the only way to do that is if you draw a spade and a spade. There's no other way. And we had 6 of these back here. Only one of these where we drew 2 spades. So we wanted overall the probability of drawing 2 spades. So that was this 1 out of this grand total from all of our possible outcomes. So that was a total of 16 for all of these, so 1 out of 16. For this one, we have a student randomly guessing answers to two true-false questions. We want the probability of guessing both answers correctly. So we can do this by making up a table and listing out the possible outcomes and then figuring out the theoretical probability from that. So here's my table. In each row I have a different number of correct answers. Now let me write down some of the ways of getting each of these. So if I got both 0 of these correct, that means I was incorrect on both questions. So I is how I'll show that. And there's only one way to do that. If I want to get one correct, I could get the second question correct or the first question correct. Either way. So two ways to do that. And to get them both correct, I need to get questions 1 and 2 both correct. So only one way to do that. So the number that we wanted both correct. So that's in this 2 column here. That's a total of 1. And the grand total of all the possibilities, there was 4 different things that could have happened, so 1 out of 4. On this problem, we have 2 6-sided dice being rolled, and they're showing us all 36 possible outcomes. They want us to find the probability, firstly, that the sum of the 2 dice is not 4. Well, it would probably be faster to figure out the probability that the sum of the dice were 4, and then just subtract that probability from 1. Use the complement, basically. So probability that the sum equals 4, let's count up how many there are in that category. So we've got the 1 and the 3, and all the sums are the same on each diagonal the way this is laid out. So 1 and 3, 2 and 2, 3 and 1. So we have a total of 3 out of 36 that have a sum of 4. That means there's 1/12 out of all our possibilities that are going to be a sum of 4, which is exactly what we don't want. To get the ones we do want, we just have to subtract 3 over 36, or 1 over 12, take your pick, from 1. So the sum that it's not 4 is going to be 1 minus 1/12, which would be 11/12, because this is really 12/12 minus 1/12. So 11/12. Now we're going to do another question asking about the sum is. Let's have one is there. So the sum is greater than 5. So there's a lot of possibilities where we have greater than 5. Here's the diagonal right here where we have a sum of 5. So everything past that is going to be greater than 5. It might be a little faster just to figure out the things that are not greater than 5, namely the sums that are less than or equal to 5. That's going to be all the diagonals up to and including this 5 diagonal. So we have 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10 possibilities for 5 or less. So that's 10 out of 36, which I could reduce if I wanted to 5 out of 12, 5 out of 18 rather. So we've got 5 out of 18 that are not greater than 5. So the greater than 5s are going to be 1 minus 5 out of 18. That's 18 over 18 minus 5 over 18, which comes out to 13 over 18. On this one, we have the age distribution of guests at a cultural festival shown in this nice little 3D pie chart. We want to find the probability of 2 things. First, they want to know probability that a person chosen at random is at least 15 years old. So there are a lot of different age groups on this one, and a lot of them are older than 15, at least 15 or older. So it might be a little faster to figure out the ones that are not 15 or older and subtract those percentages from 100. So that's what I'll do first. I want the probability that our age is less than 15, the opposite of at least 15. So which ones is that going to be? Well, we've got the youngest of the age groups, the under 5, so that's going to be a 7 right there. And then 13 is the 5 to 14s. So we've got a total of 20% who are under 15. That means that at least 15 or older is going to be 100 minus that 20% for 80%. Next up, we want to know probability that a person chosen at random is not 25 to 44. So 25 to 44 is these 2 slices right here. Again, it's going to be faster to calculate the opposite of what we want and then subtract that from 100. So let's find that complement. So probability of being 25 to 44, that's going to be this 13% here plus another 13%, which gives us 26% of what we don't want. So then the probability of not in that age group is going to be 100 minus 26, which is going to be 74%. On this one, we are picking a card out of a standard deck of 52, and we want the probability that the card is each of the following. So first we've got a red face card. So overall we've got 52 for the denominator. That's kind of our starting denominator. In terms of red cards, there's 26 of them. That's half the deck. In terms of face cards, there are the Jack, King, and the Jack, Queen, and the King from the hearts and the diamonds. So that's a total of 6 face cards that are red. So 6 out of 52 is kind of our starting point on this. And then we can reduce that to 3 out of 26. Next up, we want a club that's less than 6. Well, there's 13 clubs, and less than 6 means ace, 2, 3, 4, or 5. The ace counts as a 1. So that's a total of 5 out of 52 total, which we can't reduce. So that's just going to be our answer. And then finally, not a heart face card. This one, it might be easier to figure out how many heart face cards we actually have, and then subtract that from 1, or 52 over 52. So there are 13 hearts. 3 of them are face cards. Again, the Jack, the Queen, and the King. So we have heart face card would be 3 out of 52. So 1 minus 3 out of 52. There we go. Not heart face, not king. 1 minus 3 out of 52 is going to give us 49 out of 52, which can't be reduced at all. So that's just going to be done.